right, exercise 4. So in this exercise, again, we're given an actual equation. We're told to interpret the slope. This time we don't have multiple choice. We're going to have to do this from scratch. And I know that interpreting the slope is that sentence, for every one. And now I need my units of x, which means I have to actually read the question, figure out what x is. Total team salary, it looks like they've defined as x. And number of wins is y. And they've given us some units there as well. So for every one x, and it looks like that is in $1 million. So I'll go ahead and throw a dollar sign in front. So for every $1 million increase in total team salary, the number of wins, and by the way, exercise 3, I should have had some language in there so that it didn't seem deterministic, but my answer was it didn't. Number of wins is predicted to increase which is a really silly amount. So what you could do if you really wanted to, you could multiply this through, like try to change this up. You can make this for every 100 million. We could now say you'd have 6 more wins or something. That's perfectly fine, as long as you keep them right proportionally increasing is perfectly fine. But you could have left it the other way and you'd be perfectly fine. They wouldn't have been mad at you. All right. So a team spent $60 million on salaries. If the residual is negative 1.503, what is the true number of games won? So if you didn't pause and try these on your own, do so now. Try this one, see if you could do it. So we were given 2 different numbers and then we were asked for something. So first thing we were given is 60 million, which we know is about the team's salary. Now, this already was in millions of dollars, so no reason to write a crap ton of zeros here. The residual was 1.503, that's our E. And we're looking for the true number of games won, which is our Y. Right, so we're looking for real Y, not Y hat. So that would be a very common mistake. So as soon as we mention this residual, we probably want to write down the residual formula, right? Actual minus predicted. And just like the last problem, we have E, we're looking for Y. If only we had Y hat. And just like the last problem, we can, right? There's a step 1. Let's go get Y hat by using that equation for the line. 0.062, and we're just going to plug in that X of 50. Whoop. 1.783. Bah. Plus 0.062 times 50, that is not a 2. So we'd expect 4.883 wins. Is that right? Sorry, we were supposed to multiply by 60. I knew that number was wrong. I've done this problem before. I don't know why I wrote 50 here. It's 60. I'm sure you guys were yelling at the computer screen. Let me change that. Aha, 5.503. That seems like some number I've seen before. So we expected 5.503 wins. And now we can go ahead and do step 2, plug into that residual formula. We had negative 1.503. The actual Y is what we're looking for, and we got out 5.503 as our prediction. And if we want to solve this equation, we just need to add that 5.503 to both sides. So it turns out our true Y is 4 wins. I should have given myself way more space for this problem. All right, so we have now, for a regression line, we have interpreted slope, we've interpreted y-intercept, we found y, we found y hat, and we found e. So we found all 3 of those. Those are really the only 3 things they can ask you to do with this line. So again, I'll pause. I'll make another video for exercise 5. You can try it on your own. Fast forward to the end, see if you got it right, or just check with somebody else if they've filled it out before class. But you're not required to watch it unless you want to practice another one with me holding your hand.